that we have going on up at Pax River. And over to Pojo.
Good afternoon. I'm Matthew Dominic, call sign Pojo. Really excited to share some of the really cool things we get to do at PAX. I was a Fleet JO in VFA 143, the Pukin Dogs. I then had a really great opportunity to head to grad school in Monterey. Started my master's there, and I finished it at Test Pilot School in December of this last year. And then I've been at VX-23 since. Really loving it over there, but more importantly, I'm here celebrating carrier aviation with everybody. I'm going to talk about something we call shake, rattle, and roll. In carrier suitability, we want to make sure every carrier-based aircraft and/or weapon system can survive the toughest carrier landings or catapult shots. We do this by flying to the design limits of the aircraft. To put it simply, we intentionally abuse the aircraft, and then we check and see if it still works. Right now overseas, while we celebrate carrier aviation, our brethren are on the USS Bush flying daily missions against ISIS. As carrier suitability pilots, we don't want a bomb or fuse to fail. We don't want a bomb to go off target because of a previous hard carrier landing or catapult shot. When a Prowler or Growler Echo commands it, we want every bit of electronic Armageddon raining down upon the enemy. Here's how we make that happen. We have some really, really amazing test assets at Pax River. Right here on this left display, you'll see we have a runway with the runway 32. And we have a ship arresting gear system built into the runway. Cable risers, metal deck plates, non-skid, the whole works. The angled concrete on the left of the runway there is our land-based steam catapult. It's a little shorter than the steam catapults you'd find on our Nimitz-class aircraft carriers. To give you perspective for test points, we've hit 5.5 Gs. In fact, just a couple weeks ago, I did 5.5 Gs through the chest, into the seat. Your typical carrier catapult shot peaks out mainly about 2.5 G. So we're doubling that and then adding some change. So here's a land-based catapult shot at Pax River. I'm telling you, it's quite a hoot to ride. In addition to catapults, we get to do arrested landings to simulate the roughest conditions we could anticipate on the carrier. Imagine trying to safely replicate the worst landings Nuggets could throw at you. Then we go a little bit farther and simulate dirty hinge approaches. We fly a bunch of different types of arrested landings in order to reach the edges of the aircraft design limits. Truly precise edge of the envelope flying. Here's your video first in full speed and then at 1/10 of speed. In this test point, the pilot is intentionally cross-controlling the aircraft. He is slipping all the way to touchdown, trying to simulate a moving carrier flight deck or a lake correction. Watches the wire whips up and yanks around on the hook and really stresses the aircraft. We want to make sure that those two bombs will still function in a later flight. In the subsequent video, we've got a Hawkeye. In this video, the pilot intentionally rolls and yaws in the same direction just prior to touchdown. Timing is absolutely critical in this test point so that you don't exceed the limits of the aircraft or the arresting gear system. Bolter, bolter, bolter. Power back on. You can see these are really, really challenging test points to fly, and we really enjoyed doing it. We also conduct something called free flight landings, and it's defined as when the hook catches the wire before the main gear touchdown. So here we go forward, and we see that the hook is just catching that wire. One more frame, and we see it's very clear that the main gear are off the deck and the hook is up. Our window for conducting this test point is about that big. We've got one wire out there, and we set the lens right on top of the wire. We're targeting it. It's a good, strong integration between test pilot and test LSO with really critical and timely, easy with it, and attitude calls. It's critical for safety of flight that we have a rate of descent during this test point. We'll watch that there. If we have a rate of climb when we do this, it's a little bit dangerous, but it's not something we try to do. We avoid this. Here he catches it with a rate of climb. It's not intentional. Of note, the airplane came out just fine on this one. The pilot had a little bit of a hurt back, but we try to avoid in-flight engagements. Another test point is the high sink. Has anybody ever here had a big high fly-through down at the ramp? Traded a high ball for a low ball? No, nobody. Everybody here flies cresters and center balls, I'm sure. In this case, we're trying to simulate that underline fly-through down at the ramp while the deck is coming up to meet your aircraft. So we're intentionally flying a 6-degree glide slope here. We set our flaws to 6 degrees, and this is an approach at Pax River. We're doing about 12 to 1,300 feet per minute rate of descent all the way to touchdown. It's really hard not to want to pull back and avoid this landing. I love doing that. The last shake, rattle, and roll arrestment we will talk about is off-center engagements. We have to target between 17 and 20 feet. If we go outside of 20 feet, the arresting gear is down for 24 hours, and you're slowing down test for the fleet. So this is a T-45. I love how the cable jerks that little T-45 around. So overall, shake, rattle, and roll test points are challenging, but most importantly, they're a boatload of fun to fly for us. Another one of our responsibilities in carrier suitability flight test is to make sure that precision approach and landing systems found on both our angled deck and our amphibious flat deck carriers function as advertised. These are the ACLS and ICLS system we use to get aboard during Case 3 flight ops. We fly a lot of Mode 1 touch and goes to verify the systems are working. That Mode 1 is that automatic carrier landing where the airplane receives guidance from the ship. The pilot monitors the approach. We visit each ship at least every 2 years to thoroughly groom the ACLS and ICLS systems. We want fleet aviators to have confidence in the system so they can have it when they need it. Here we have a side-by-side video. I'm just going to talk and explain what's about to happen. On the left is a day VMC Mode 1 approach we flew for flight test. That's just the HUD video. On the right is an actual Mode 1 approach flown in terrible, terrible weather where the pilot could not even see the ship. The approach on the left will not come into view for a few moments, so be patient with that. But these are separate approaches that we sync together for comparison. We will hear the audio from the approach on the right, the ugly one. The first words you will hear are the pilot calling the ball coupled, indicating that he's flying an ACLS Mode 1 approach. Here we go.
Coupled. House contact, you're on, glide slow, coupled. On, glide pedal. On, glide pedal. On, glide pedal, on, on. On, glide pedal. Touch it down. Thanks, Kels. You are.
I get absolute goosebumps every time I see that pass on the right. Confident that that system works. We work on these systems every day so that our guys can get aboard safely in the worst of conditions. ACLS approach has been used for quite a long time. In fact, the first ACLS flight test was conducted in August 12, 1957. Lieutenant Commander Donald Walker, are you here? All right. USS Antietam. He rode that all the way to the deck. I didn't realize that we went back that far with this. He was in that. That's an F-3D Skyknight. The ACLS system is going to be replaced by JPALS, the Joint Precision Approach and Landing System. It is a differential GPS precision approach system. It's displayed to the pilot in the same manner that ICLS would be. It is currently slated to be installed in F-35 and U-Class. U-Class is the follow-on to X-47B, which we'll talk about in a moment. Same on the X-47B had a very similar type system to land aboard the ship. In fact, you're watching passes from Flanders, Hu, and ROTC from last November. They're seen flying right up here. They performed the first coupled landings using this production JPALS system. The F-A-18 was used as the surrogate. I'll now pass it off to Flanders. You're going to have to bear with him. He's a newly minted dirty hinge and recently had a lobotomy.
All right. F-35. I got a couple questions for you. Who here has heard a rumor about F-35s at any time? Anybody? Anybody heard a rumor? Okay, here's my second question. Who here has heard a positive rumor about F-35C? Yeah, not many hands, right? In all reality, yes, there are challenges, but I defy you to name a single DoD acquisition program of this size that doesn't have challenges. And honestly, that's our job to discover those challenges, and that's why we get paid. So we like that. All right. What I'm going to tell you that is not a rumor is that CF3 is back. That's the Carrier Suitability Test Aircraft. That's the third C variant made. The ITF and the entire JSF team is hard at work executing carrier suitability testing every single day. They work in Monday through Friday and many Saturdays trapping the aircraft at PAX. They're currently in the middle of their structural survey. So structural survey, Pojo talked to you about shake, rattle, and roll. So structural survey is shake, rattle, roll on steroids for new aircraft. So normally when we do shakes, it's for a specific system or component on aircraft, but a structural survey is for a brand new aircraft. So think of that 6-degree glide slope landing that Pojo showed you. Now take that 6-degree landing and put that at a level attitude instead of on speed, and then hit the ground. I can tell you they're not comfortable for the pilot or for the aircraft, but that's how we test those corners of the envelope for a brand new aircraft. All right, another interesting fact regarding carrier suitability and the F-35 is what's called delta flight path. Think of it as a direct corollary to magic carpet. It's the same conceptual idea of landing at a ship. The flight control surfaces are providing that direct lift, so you have that direct connection to the glide slope and the ball, while the system itself maintains that quote-unquote ideal glide slope for you. That's how the F-35 is going to go to the ship. That's the option. And that's how they're going to put it out to the fleet. And it's working pretty well. Currently, the F-35 is scheduled for the first trap on the mighty USS Nimitz later this fall, and honestly is well on its way to achieving its goal of cruising 7 seas as the Navy's first fifth-generation fighter.